Okay, now we're into a little work with fractions. Everybody got this step and did a great job with that, okay? As I was hoping and I pretty much expected, but you never know, okay? So you get x squared minus 5 halves x minus 5 halves x. Well, 5 halves and 5 halves is 5. And we're going to, next thing we're going to do is we're going to review fractions because that's going to become very important. But that gives you the minus 5x. 25 fourths, well 4 goes into 24 6 times, leaving 1, so it's 6 1/4. Yeah, it's 6 1/4, right? 6.25, and 6.25 minus 12.25 is negative 6, right? So this equals x squared minus 5x minus 6. So we just showed that they're equal, okay? Now there's a process called completing the square. I'm going to show you that a little bit, and then we're going to move over to review of fractions, okay? Because my experience is that due to misuse of calculators and holes in the curriculum, almost everybody is weak on fractions. And you really can't be, because right after quadratic functions, or very soon after, you get into rational functions, and you got to really understand how to manipulate fractions. And I find that if we do a good review of fractions, that ceases to be an issue. Okay, there are other things that are issues, but we get that out of the way so it doesn't cause a stumbling block. And it's a stumbling block for everybody. Out of a class of 20 people, only 3 of them might sort of know fractions well enough. Okay? So you've got to spend time on it. Okay, so anyhow. Okay, so if we have, again, f of x equals x squared minus 5x minus 6. And we want to put this into the form x minus h squared plus k, where h is your horizontal shift and k is your vertical shift. One way to do that is to use the quadratic formula and figure out where the vertex is. Okay? Because the coordinates of the vertex will be your h and your k. There's another way, and it's kind of an important technique, but it's related to factoring. And so far we haven't talked about factoring, so I want to talk about that just a little bit. Okay? And my experience is that people are usually pretty decent with basic factoring after a little review, but if we find out that that's not the case, we'll do a little more work on it. Okay. Okay, first of all, we're going to digress for a minute to factoring and say that, okay, x squared minus 5x minus 6 equals x minus, write down the x would be better, x minus 6 times x plus 1, right? And from this, you can easily determine that your zeros have to be 6 and negative 1, because for this to be 0, this has to be 0. For this to be 0, either this factor has to be 0 or this one does, right? Well, what number would you replace x with to make this factor 0? What minus 6 equals 0? 6, right? So if x is 6, this is 0. And if x is negative 1, this is 0. Okay? So if x is 6, the whole thing is 0 because you multiply these things. This is 0, so whatever you multiply by is 0, right? And this, for x equals negative 1, this would be 0, which would make the whole thing 0. Okay? Okay, now I'm just mentioning that, but we can factor this thing. Now, that's just a quick digression. Okay, now let's say we've got x squared minus 5x. Okay? What's the answer to the question mark that makes this a perfect square? Well, you've already seen the answer, but how would you get the answer if you didn't already know it? Well, we've seen we've just seen this, if you think about what you just did when you expanded this, right? Okay? Because when you multiply this out, you get the 5 halves and the 5 halves twice in front of x, right? Which is what gives you a negative 5x. Well, if you didn't already know that, how would you find it? Okay? Well, I'm going to say that x squared plus bx plus the square of b over 2 is the square of x plus b over 2. So I've been kind of roundabout in getting to this, but probably mentioned too many things. So let's just verify this. Can you write out x plus b over 2 squared and then use the distributive law to square it? Well, I think you can, so I'm going to do it for you. So I'm going to say check this. I think you'll recognize this since you just squared the x minus 5 halves. X plus b over 2 times x plus b over 2 equals x times x plus b over 2 plus b over 2 times x plus b over 2, right? That's just the distributive law. And what's x times x? Well, you know that's x squared. You wrote that down right away, okay? Now, if it was a 5 halves, we would have 5 halves x. Well, it's b over 2, but that's still just b over 2x, isn't it? X times b over 2 is just b over 2 times x. And then b over 2 times x, well, no big surprise, that's another b over 2x. And b over 2 times b over 2 is b over 2 squared. So that when you add these, you got it. So you can say here, yep, works out. get this. Okay? So if we were given this, x squared minus 5x minus 6 can be written as x squared minus 5x minus 6. We're going to concentrate on what's in here. We're going to add whatever we need to make this a perfect square. Now what do we need? We need to add 5/2 squared, right? So we can say that this equals x squared minus 5x plus 5/2 squared. That's in this form, right? In other words, we add the square of whatever's here. Now, officially, if we're adding the square of this, we'd add the negative 5/2 quantity squared. But when you square it, the negative sign goes away anyway, okay? Okay? Now, we're saying this should equal this. And if I just add a negative 5/2 quantity squared, I just changed something, didn't I? So what I do is I subtract. Negative 5/2 squared. So I haven't really done anything. You got to agree that this is equal to this because this negative 5/2 squared and the negative of the negative 5/2 squared add up to 0, right? There's no change. But then I can regroup this. Like so. I have no idea why I did that. I'll tell you in a minute. Okay? This is just x minus 5/2 squared. Okay? If you square this, this is what you get. And negative 5/2 squared minus 6 is negative 12.25. So right here we've got our horizontal shift and our vertical shift. Okay, now what I'm saying is try the same thing with x squared plus 4x minus 9. Because this is all kind of convoluted. Probably have to look back at it to understand what I was saying, what I'm getting at. But you want to just focus on this and this. Okay? Don't worry about any of the rest of it. You have this, and we do this. Okay? So this should equal first we're going to write it this way. And what we're doing now, we're going to add something to make this into a perfect square. Okay? And then we're going to subtract that same thing. So according to this, we have x squared plus bx. That's our x squared plus 4x, right? So now this is x squared plus bx would be equal to 4. Okay? To make it a perfect square, we've got to add b over 2 squared. Okay? We're going to add b over 2 quantity squared, then subtract it. So we have x squared plus 4x plus something minus 9 equals 0. And whatever we add, we've got to subtract so we don't change this. So what's our b over 2 squared? B is 4. So b over 2 is 2. We're going to square that. Well, I'm going to write it as 4 over 2 squared. Didn't leave myself enough room, having an epidemic of that. But I'm going to do 4 over 2 squared minus 4 over 2 squared, plus 4 over 2 squared minus 4 over 2 squared, just to connect with this. And 4 over 2 is 2, and you square that, you get 4, don't you? I don't know why I've got equals 0 in there. I mean, we'd want that if we want to find the intercepts. We're not doing that right now. Okay? So, we take that 4 that we subtracted, we do the arithmetic, and we see we can just rearrange it. We get this. So we get a minus 13. Okay? And what's x squared plus 4x plus 4? We factor that into x plus 2 times x plus 2. That's x plus 2 squared minus 13. Vertex is -2, -13. Because remember, your horizontal shift to get up x plus 2 has to be minus 2, right? That's a lot. I'm going to give you just a little bit to do on this, but mostly just make sure the process that we did over here, where you figure out the vertex and do the shifts, the transformations. But that leads into this, and I'm probably going to ask you just questions like, what do you have to add to x squared plus 6x to make it a perfect square? Okay? And then we'll try to work it in to this, which gives you a really good tool. That's actually kind of a little bit hard, okay? By far the hardest thing you've seen so far. And one of the harder things you see in the course, but let's see if we can gradually work this into something that we understand. Okay? Can be an important technique. Also, if you can do it in my class, you like to, probably going to appear on a test, you're going to make a much better grade. Okay? And you're probably going to do it in your class. You're probably going to have to do it. Okay? Won't be a big deal, but you get an extra half a letter grade by knowing how to do it, probably. Okay? That's worth it. Okay, very good.